All right, so last lesson of this unit, 6.6, transforming sinusoidal functions. So this is sort of a collection, a consolidation of everything we have learned. All right, if you've been following along and taking notes, you will have seen all of this information along the way, and I would have mentioned it several times throughout. Okay, so this first box you see at the top here, that's just a nice summary that goes through everything that we've talked about previously. It talks about the A value, how it's responsible for the reflections, stretches, and compressions, right? Like that's this column, right, the box right here. And then you have the one right below that, the C, that talks about the shifts left and right, the phase shift. All right, that's just the actual correct terminology. And then you have the vertical translation, right, the D value on the backside that moves things up or down. We have also seen that the amplitude, right, we've used this mathematical equation. Okay, so let's just highlight some key things here. So we have this right here. That is a very small highlighter. Let me make that bigger. There we go. We have the equation right there. And then we've also been able to see from just directly looking at a given function, well, we can just say, well, the amplitude is the magnitude of the A, right? It's just like whatever that A value is on the front side there. The equation of the axis, same thing. We have a mathematical formula. You can look at a graph and calculate it this way. Or it's just the value of the D on the backside. So the equation of the axis is, if you have, it's just D. It's y equals D. It's just the thing that's on the backside. So if you have sine x plus D, it's this right here, the thing on the backside. And then lastly, the transformation C, it doesn't have as easy of a way to look at it as looking at the A value and the D part of the equation. You can't directly look at it from a graph. So for this, what we're going to have to do is you eventually have to sub a point in to solve for the C value. The C value, okay? And that's what this means, is determined by estimating the required horizontal, or just estimating. So you have to calculate it. You can't look at an equation or use one of these formulas that we have here. So we'll do that. Actually, well, first, we use the 5 key points to sketch the graph of the sine function. The 5 key points. So this actually will apply to example 2, but let's just put them. The 5 key points are 0 degrees and 0, 90 degrees and 1. We have 180 degree and 0. Again, this is just a recap, right? Like we've done so many examples where we just had to keep using these points, but we'll need this for the second example, so we'll just have them here. Okay, so example 1. This is where we're going to create an equation based on a graph. So what we're going to want to use is, if I give you a graph, right, use these values, right? If given a graph, just directly look and see what your max and your min are. So I look here and I say, okay, well, I can calculate my A value by just saying, all right, max minus the min value all over 2. So look at your graph and say, well, what is my maximum? Well, right here, that's the peak, that's the max, and that's at a value of 60. What's the min? Well, down here, I look at it and I say, oh, that's minus 60. So 60 minus 60. So just careful with your negatives there, okay? 2. So up top, you're going to get 120. Divide that by 2, and you'll get 60. Now, we don't know the units because they haven't given us anything, so it's just 60. Do the same thing for the D. So the D is now max plus min divided by 2. Well, we have those numbers. It's 60 and minus 60. So 60 plus minus 60 just ends up being 60 minus 60. Divide that by 2, and you get 0. All right, well, so far, if we write our equation, we have y equals a sine x minus c plus d. Well, we know this right here to be 0, and we know this to be 60. So let's add those. This is 60 sine x. I'll put this in green, C, and then plus 0, so we don't have to write that. So we need that C value. So sub a point. Sub a point into the graph, because the only thing you won't have then is you won't have the C value, because you'll know X's and Y's by subbing a point. So the easiest point to identify on a graph is just look for the max or the min, right? So this point right here occurs at an X value of 90 degrees and a Y of 60. So you're subbing in the point 90 degrees, 60, right? Like this is your X, this is your Y. So you plug in 60 equals, I'll write it in blue, 60 equals 60 sine X, and then we're finding that C, okay? So then first thing you need to do is still following order of operations, right? But reverse order, you need to get rid of this 60 first, okay? So divide both sides by 60. So that would cancel. And you bring it over here as well. 60 divided by 60, that gives you 1. So 1 is sine X minus C. Now we need to get rid of this sine right here. So how do you bring sine across? Do you divide by sine? No, do not do that. You take the sine inverse. So the sine inverse of 1, and you would do that to this side too technically. So these would cancel, and you get X minus C. Oh, sorry, why did I not plug the X in here? X, I'm sorry. So that should have been 90, 90, 90. There we go. Sorry about that. Okay, so sine inverse of 1. Well, just use your calculator. Take the sine inverse of 1, and your calculator will give you a value of 90. And that is 90 degrees. Remember, when you take the inverse of sine, you're finding a angle. So 90 degrees equals 90 degrees minus C. So bring the C to the side, bring the 90 to the other side. You get C is 90 minus 90, or 0. So we do not have a phase shift at all. So our final equation is y equals a, which is 60 sine x. That's because both C and D were 0. So this equation is for this graph right here, right? So now, given equation, give me a graph. Well, whenever you're graphing, just like we did in the quadratic unit, use the mapping rule. It's the easiest way to go about doing it, okay? So our mapping rule, remember, is x plus c, right? So you transform all your x coordinates by just adding your phase shift, and then all your y coordinates are multiplied by your amplitude, and then the equation, or the axis, adding the axis on the backside. So plus d. So in order to apply the mapping rule, you need the parent function points, and that's why I kind of said that in the beginning there, those 5 key points that we have, right? These ones right up here. So those 5 key points are 0, 90, 180, 270, these are all degrees, 360. And then your y points, right, because remember you're calculating y based off taking the sine of all of these inputs. So it's 0, 1, 0, -1, and 0. So let's transform these points. Transforming them, well, let's make our chart again. So we're taking x, and what is our c value? Well, right here, it's 45. Your c is 45. Your d is 2, and your a is -3. So adding 45 degrees, and then your a is -3 times y plus 2. So you're essentially just taking all of these values right here, and you're just adding 45 degrees to them. So if we do the first one, it'd be 0 degrees plus 45 degrees, so 45 degrees. And if you did it for the 90 degree, I'll show you just one more, you get 135 degrees. So if you just do it for each one, you get then next 225, then you would get 350, 15 degrees, and then you would get 405 degrees. Okay, the last one, minus 3y plus 2. Well, here you're just taking all of these values and substituting them in for this y right here. So the first one would be minus 3 times 0 plus 2, so 2. And you do that each time, so then you get 1 subbing it in, that'd be minus 3 plus 2, so minus 1. 0 times negative 3 is 0 plus 2. Negative 1 times negative 3 is 3 plus 2 is 5. And then 0 times negative 3 is 0 plus 2 is 2. So these are your new ordered pairs, right? 45 and 2, 135 and negative 1, 225, 2, 315, 5, 4, 5, and 2. So all you have to do now is just plot those points, and then you've already done your transform graph. So we have to go all the way from 45 to 405. So let's just keep what we've been doing so far in the videos. You know, we start at 0. Every one of these will be 30 degrees, so 30, 60, 90. Actually, you know what? We're scaling up by 45, so why don't I move by 45 actually? That'd probably make more sense. So then 45, I'll make this one 90 degrees, and then add another 45 to that. That'd be 135. Add another 45 to that, that'd be 225. So you know what? I'll just do each one as 90 degrees, so that way we don't mess up and run out of space. So there's 180. And then I'll make this one 270, and then that would be another 90, so that would be 360 here, and we have to go all the way up to 405, so add another 90 to that. That would be, my mental math is 450. Perfect. Okay. Oh, actually my scale will not be great. It's okay, we got the idea. So we're plotting the point 2 and 45. So 2 and 45 would be right here. There's the coordinate. This is 45 right here. So you go, so there's your first point, 2 and 45. And then you have your next point, 135 and negative 1. So halfway between these, this is 135 here. So 135 and negative 1, right there. Then we go to 225, so that would be right here. So it's halfway between all the green markings I've done. 225 and 2, so that's right up here. 315 and 5, so 315 and 5, that's way up here. And 405 and 2, so 405 and 2, that would be right here. Perfect. And so let's connect our dots. So this is our starting point. We go down, we go up, and we go down like that. And you can see we have our equation of the axis right here. This is y is 2, right? It cuts the graph in half. There you can see it's at the value of 2. You can see we also, from 2 all the way to 5, that's 3 units, right? Well, look at our a. Our a was 3. So we did that correctly. And the other thing too is typically sines go up first and then come down. But notice how we're going down first, so we also satisfied the negative. And then the last part is, we also usually start right here at the origin, but we're 45 degrees off of that. So that is the graph. This is the graph f of x equals minus 3 sine x minus 45 degrees plus 2. So then we need to state the amplitude, period, and equation of the axis. Well, it's already stated the amplitude. The A, your A is 3. Your equation of the axis, all right? So I'll give you a chart to do this on the test, but your amplitude, I'll just make it cleaner. Amplitude equals 3. Your axis is y equals 2. And your period, remember periods are always 360, but you can go from the highest value, 405, take away 45 degrees, your starting point, and you'll get 360. So period's 360. And then I think that's each one. We state the amplitude, period, equation. Perfect. Describe the transformations that were applied. Okay, So state them in order. Remember, you read it left to right. Okay, so left to right. So the first sentence, we'll talk about that negative. This is a reflection over the x-axis. The next one you have is a vertical stretch by a factor of 3. And then you have that 45 you talk about. So that was a horizontal shift by 45 degrees. Oh, sorry, shift right 45 degrees. And then the last one was a vertical shift up 2 units. Example 3. For the following function, a vertical and horizontal translation has been applied to your base function, f of x equals sine x. Determine 2 possible equations for the function if this function has a domain of x belongs to real numbers and a range of 44 to 46. Okay, so first off, the domain. In all the videos, we've talked about the domain being from 0 degrees less than x less than 360. What this is saying, the reason it says x belongs to real numbers here is because you can create 2 possible equations that have any kind of phase shift. I don't care where they are. You can have limitless possibilities. You can have a massive horizontal shift. It doesn't matter. Your domain can be anything. So what this is saying is that the c can be any value. All right? I'm not telling you where you are, where you're constrained with. You're fully open. So using that piece of information, I can say, okay, well, I'm going to create a sine function. So my first function, my first one, I'll make it y is sine x plus 45 degrees. Cool. There we go. But now I also need to deal with this. The range is between 44 and 46. So what that means is if you had a graph, right? If you had a graph of sine, it's way up here where you're going to look like this, where you're going to go up to a maximum value of 46. And then you're going to go down to a minimum value of 44. And you're just going to oscillate between those 2 values, right? You're somewhere between those 2 values. So this is your minimum. This is your maximum. So if we know our minimum or maximum, remember our A is our max minus our min divided by 2. So that means you're 46 minus 44 over 2. So that will be 2 over 2, giving you 1. And then your D value is the same thing. It's max plus min divided by 2, giving you 46 plus 44. Divide that by 2. So what is that? That's 40, that'd be 50, that'd be 90. Divide that by 2 is 45. So now let's add that to our first equation. So we need to have an A value of 1, and we need to have a D value of 45. So those purples need to be there. But this can be anything. All right, so there we go. That is one final answer. That satisfies all the constraints that it gave us. We have found our A, we found our D value, and we have a phase shift. Our second equation, again, C could be anything. So we can make it Y, and that A value, by the way, right? Like I could also make this, because the amplitude is 1, but I can still oscillate between 44 and 46 if this was a value of -1. That would also be valid because you still have a distance of 1 there. And I can make this anything else. I can also say, why not make it like a weird number, like 37 degrees. You know what I mean? Like it doesn't matter. Plus 45. So really, it's just understanding how to go from domain and range to be able to get your D, your A, and your C values, okay? So there is your second equation. Last example, draw a diagram for a water wheel that could have formed the function h of x equals negative 5 sine x minus 30 plus 2, where h of x is the height in meters, x is the number of degrees the wheel has rotated from its original position. Include all relevant measurements on the diagram and indicate the direction the wheel is rotating. All right, so let's look at this graph and say, all right, what are the key pieces of information I have? What is it that I'm graphing? Well, I'm having an amplitude of 5, right? I have here, this is my axis, right? So I have an amplitude of 5 and I have an axis of 2. So if I'm going to draw my graph, I don't want to run out of room, right? Like I need to go up and down 5. Like when you have an amplitude of 5, it means that like from your center line here, you're going to be 5 that way and you're going to be 5 this way. That's what that 5 represents. So if I was to, and I'm also shifting up 2. So let's figure out what axis I need to go. If I make this 1, 2, 3, 4, 5, 6, 7, if I start at 2, yep, I have 5 units to go up. Perfect, let's keep that scale. So let me just make it a little nicer. So I can make this 1, 2, 3, 4, 5, 6, and 7. And what I was saying was like, oh, okay, well, I know my axis needs to be going through 2, like this. This is where my y equals 2 is from. And that's just reading right off the graph, right? That's this equation, sorry. That's just this 2 right here. And I was like, okay, well, I know I need to go an amplitude of 5. So do I have a room of 5 to go up here? I do. Perfect. So right now we'll leave it like that. That is a good scale to use. So I'll just use my negatives, 2, 5, negative 6, negative 7. All right. And now the graph is saying, okay, well, we're moving over 30 degrees. So we'll just make sure each one of these takes us 30 degrees again, like we've always done. So 30, that means, so this is 30, this would be 60, this would be 90, and 120, 180. Oh, sorry, that's not 150, 180 would be right here. Go over 3, 1, 2, 3, this would be 270. And then 1, 2, 3, this would be 360. Okay. So we have a phase shift of 30 degrees. So if you think about your sine function is usually starting at 0, 0 and going up, right? Like it has a up like this. But now it's telling you, okay, you're not starting at 30 and 2. You're starting actually, so you're not starting at 0, 0. You're starting at 32, right? Like you're starting at your C value and your D value because this 0, 0 point right here has shifted. But another way to prove this is use your mapping notation. So we have X, we have Y, because ultimately you're trying to graph something, right? So find where all your new points need to be. 90, oh, sorry, let's make that cleaner. 90, 180, 270, and 360. So we know our points are 0, 1, 0, minus 1, 0. And just put your new equation over here. You have x plus 30 because it's minus 30 in there. And here you have minus 5y plus 2. So all of your angles are just being added up by 30. So this now starts at 30. That's what I was trying to say right here. You start at 30. Right? Like if you come with practice, you'll be able to quickly identify where your starting point is. But it's okay if you don't right now. So 30, and then you take this 0, you plug it in here, and you'll get 2, because it's negative 5 times 0 plus 2. And do that for each of these points. So 90 plus 30 degrees, that's 120 degrees. And then you put your y value in here, that'd be minus 5 plus 2, give you minus 3. 180 plus 30 is going to give you 210. 0 is going to give you 2 again. 270 plus 30 is 300. And then negative 1 times negative 5 is 5, plus 2 is 7. And then 360 plus 30 is 390. And then 0 will give you 2 again. Okay. And actually, you know what? I'm going to shift all of my points here down because I need to go all the way up to 330. So imagine I have one more, 1, 2, 3, because that would be 390. So I need to go all the way up to 390. Okay, so we are graphing these blue points right here. So 30 degrees and 2. So start at 30 degrees, so 30 degrees and 2, right here. Right, because this is not 0, 0. This is not 0, 0. 0, 0 is technically right here off the graph. So that's 32. 120 and negative 3, so 120 and negative 3 would be right here, right? Because each one of these ticks is 30 degrees. 210 and 2, so 30 degrees, that would be here, and 2. 307, so that would be way up here. 390 and 2, so that's, I guess let's move this line right here. Extend this. That would be right here. 390 and 2, and that is the y equals 2. Okay, and let's graph it. So we go like this, we go here, we go here, and we go here like this. All right, so draw a diagram for the water wheel. Include all relevant measurements on the diagram. Indicate the direction the wheel is rotating. Okay, well, you can see that if we're measuring the height